Hello and welcome to CST EV by Chipsol Technology. My name is Engineer Obaidullah and I am an embedded system engineer here at Chipsol Technology. In this presentation, I will explain all about the Wiegand sensor, that what is basically the Wiegand sensor, the type of magnets, position of the magnet, and after that I will show you that whenever we connect the Wiegand sensor directly to the oscilloscope, so you will see the output voltage signal. And at the last I will explain the Wiegand sensor with the STM32 microcontroller, so you will see. So let's start the introduction of the Wiegand sensor. Basically, it is a magnetic device that operates without requiring an external power source. They play the Wiegand effect to produce a continuous pulses whenever there is a change in magnetic field polarity. Due to this feature and this capability, they are called a zero power magnetic device, and it is an alternative of the Hall effect sensor. This is because whenever you use the Hall effect sensor in your circuit, so it will consume a lot of power. Whenever personally I use the Hall effect sensor, so it consumed more than 2 milliampere current. So in low power devices we can't use the Hall effect sensor. Instead of Hall effect sensor, whenever you use the Wiegand sensor, so it would be very efficient in the uh, low power consumption. You can see here there are many shapes of the Wiegand sensor, like cylindrical one, and the other one is like this, which is the WG112. So the sensitivity is changing by changing the shapes of the magnetic sensor, but personally I am using the WG112 because it is a very sensitive to the magnet, so that's why we will use it in the future slides as well. Now in this slide, uh, it is basically the diametrically magnetized magnet that I will use with the magnetic sensor. In this magnet, in a single coil there is a north pole as well as a south pole, you can see here in this slide. These alternative poles appear along the diameter of the magnets. Both poles are present on each faces of the magnet. The advantage of this diametrically magnetized magnet is that it helps in reversing the magnetic field interacting with the Wiegand sensor, therefore it produces a pulses. But whenever you don't have this type of magnet, so you can use any type of magnet. Take any two magnets very close to each other, and whenever you rotate the magnet or the sensor, you will see the output voltage. So to summarize this slide, if you don't have the diametrically magnetized magnet, you can use any type of magnet by placing the magnets and the sensor like in this position. And the perfect position is that whenever you place the Wiegand sensor very close to the magnet, so you will see the output voltage. Otherwise, if you don't place the magnet and the sensor at this position, you can't take the output voltage. So this is a very perfect position, you can see. Now in this slide I want to show you the output voltage whenever I connect the Wiegand sensor directly to the oscilloscope, so you will see this is the output voltage, you can see. But the limitation of this signal is that you can't provide this signal to the microcontroller because it is a very unstable signal and the microcontroller may be damaged once you connect this signal to the microcontroller GPIO. So to resolve that problem, we can use some transistor circuit to eliminate this noisy signal, or to convert this noisy signal to the very stable PWM signal. So once once you connect the comparator, like in this case I have used the LM339 comparator. Once you connect the Wiegand sensor output to the input of the comparator, you will see the output voltage like this. You can see it is a very perfect signal, like this one, and this is the output voltage directly from the Wiegand sensor. Now you can connect this signal with the microcontroller that I have connected here with the microcontroller as well. You will not have any issue with this signal, okay? But keep in mind that by changing the reference voltage, the output voltage may be affected. Like whenever you take the reference voltage 30 millivolt, so whenever there is a output voltage at the Wiegand sensor up from this threshold voltage, the output will be like this one. Otherwise below this voltage the output will be zero, you can see. But whenever you connect the internal reference voltage, the issue is that, and the problem is that the output voltage may be changing. Like whenever the reference voltage is the VCC divided by 2 or 4 prescaler, so by increasing the reference voltage, the output voltage may be affected. But the limitation of the external comparator is that it consumes some power. So to eliminate this issue, we can use the very fantastic feature of the STM32 microcontroller that have an internal comparator. So once you connect the internal the Wiegand sensor directly to the microcontroller internal comparator, so you will see the output voltage like this. This is exactly the same voltage as it was through the external comparator, but the difference is that in this case it will not consume extra power, okay, because you can use the internal comparator of the STM32 microcontroller in low power mode. So due to this reason it will not consume any power. I will make another video on the STM32 internal comparator as well, but for the time being I will explain it like that. Whenever you connect any terminal of the Wiegand sensor to the microcontroller internal input voltage, and at the output voltage you will see the Wiegand output voltage, you will see the output voltage like this one. But again, you whenever you use the internal reference voltage, so the problem would be like that, the output voltage may be affected. So to eliminate this issue, you can use the external reference voltage. Here in this case I have used the external reference voltage, which is 30 millivolt. So in this case, whenever you change you rotate the magnet very close to the Wiegand sensor, so you will observe here the Wiegand sensor output voltage, okay. So it was all about the introduction of the Wiegand sensor, the type of magnets, the position of the magnets and the sensor with the microcontroller, and the interfacing of the Wiegand sensor with the STM32 microcontroller. So that's it. And the next video I will show you the practical implementation of the Wiegand sensor with the STM32 microcontroller. So stay with me. Thank you so much.